All right, so we have some equations here, some mathematical equations that show some population regression model, but maybe, okay, maybe some of them or even all of them, okay, is not in the correct form. Now, let's talk about the specifications of a population regression model. For population regression model, we have two ways to express it. Okay, the first way is to write down the population regression function. Okay, we have the population regression function. Wait a minute. All right, we have population regression function, okay, where we have the conditional expected value of y, okay, the conditional expected value of the dependent variables is a function of the independent variables, okay, and this function can take on various functional form. For example, it can be a linear function, it can be also a nonlinear function of x, okay, like a quadratic function or a cubic or logarithm functions, okay. And the second way, another way that you can express the population regression model is the stochastic form, okay. We have stochastic form of the population regression model. Okay, we have the observed value of y. Okay, the random observed value of y is equal to the conditional expected value of y. Okay, and plus the disturbance ui. All right, so we have two ways to express the population regression model. The first one show the deterministic relationship between the independent variable x and the conditional expected value of the dependent variable y. Okay? And the second way, the stochastic form of the population regression model will show the statistical relationship between the independent variable x and the observed value of y. Okay, so that are two forms of the population regression model. Okay, the stochastic form will have ui with it, and the population regression function will not have ui. Okay, and remember, in the population regression model, we have the parameters. Okay, we have the parameters beta, beta 0, beta 1, and later when we study the multiple regression model, we will have more beta in our model. Okay, okay, so remember that in the population regression model, we only have the parameter beta. Okay, beta 1, beta 0, beta 2, beta 3, and so on. All right, for sample regression model, okay, for sample regression model, we also have two-way regression model. We also have two ways to express them. Okay, the first way is the sample regression function. Okay, where we have the fitted value of y or the estimated value of y is a function, okay, of the independent variable x. Okay, and this function has the same functional form as the population regression function. Okay, all right, and the second way to express the sample regression model is the stochastic form. Okay, stochastic form of the sample regression model. Okay, we have the observed value of y in the sample is equal to the fitted value of y plus the residual ui hat. Okay, or we can say that is the functions of x and plus the residual ui hat. Okay, so in the sample regression model, okay, we have UI hat, not UI. Okay, UI, the disturbance is only appear in the stochastic form of the population regression model. Okay, the disturbance is something belong to the populations. Okay, but why I had sorry UI had, okay, UI had the residuals is belong to the sample regression model, the stochastic form of the sample regression model. Okay, and for the sample regression model, we have the sample statistic. Okay, we have the sample statistic like beta 0, beta hat, beta 1 hat, okay, beta 0 hat, beta 1 hat, and we call it the sample estimator also. Okay, the sample estimator of the unknown parameters. All right, so remember that beta hat only appear in the sample regression model. In the population regression model, we have the beta, the unknown parameters. Okay, now take a look at the equations we have here. For the first equations, you can see that in the left side of the equations, we have the conditional expected value of y, okay? But in the right side of the equations, we have ui here, all right? It means that the relationship between x and the conditional expected value of y is not a deterministic one. That is not right. That's not correct. So the model one is not correct. Okay, it has not, it does not have the right specification of a population regression model. For the second equations, we see that in the left side, we have the observed value of y, but in the right side of the equations, we do not have the disturbance ui. It means that the relationship between x and y is a deterministic one. Okay, not the not the statistical relationship. Okay, and that is not correct. Okay, the relationship between x and y is a statistical one. All right. For the third equations, okay, we have yi, the observed value of y in the left side. In the right side, we have, okay, this the systematic value. But this one, ui hat only appears in the sample regression model, in the stochastic form of the sample regression model. It cannot be here. Okay, so this model is not correct. And for the last one, we have the conditional expected value of y in the left side. And here in the right side, we have beta 0 hat and beta plus beta 1 hat multiplied by x. Okay, the sample estimator, the sample statistic is not are not in the population regression model. Okay, so this one is not correct too either. Sorry, is not correct either. So okay, which of the following equations has the right specification of a population regression model? And the correct answer is none of them. Okay, none of them has the right specifications of a population regression model. Okay, the right specification here can be, okay, can be the conditional expected value of y, okay, equal beta 0 plus beta 1 multiplied by x. Or we have the observed value of y in the population equal beta 0 plus beta 1 multiplied by xi and plus ui. Okay? That is the correct form of the population regression model. All right. Next, for questions 2. Okay. For questions 2, which of the following model are linear regression model? Okay. So last time when we discussed the term linearity in linear regression model, we say that when a model is said to be a linear regression model, it has to have the parameter with the power of 1. Okay, it is linear in the parameters, which means that the parameters of the model must have the power of 1. Okay, so look at those models. For model A, okay, beta 1 has the power of 1 and beta 2 has the power of 1. Okay, so this one is a linear regression model. The same happened for model B and model C. For model D, okay, let's look at beta, the intercept here. The intercept, we have the natural logarithm of beta 1. Okay, so the intercept is not the parameters with the power of 1. It is expressed in the natural logarithm terms. Okay, so that's why this one is not a linear regression model. Okay, you can easily turn it into a linear regression model by set, for example, beta 0 equal the natural logarithm of beta 1. Okay, then you will have the model, the natural logarithm of y is equal to beta 0 plus beta 2 multiplied by the natural logarithm of x and plus ui. Okay, so if you set the natural logarithm of beta 1 equal beta 0, then the model will turn into a linear regression model. But right here, it is not a linear regression model. Okay, so the correct answer here is A, B, and C. Model A, model B, and model C are the linear regression models. All right, now let's check your answers. Okay, for questions 1, we have only 25 over 77 answers. Okay, we have only 25 correct answers, 32%. Okay, and for questions 2, we only have 38% of the responses are correct. Okay, so it is not a very high number. Okay, you have to review the lectures. You have to review the materials to get better understandings of the problems that we discussed in the last lecture. Okay, that are all very basic things. Okay, and you have to master them in order to get better understanding, in order to easily understand later topics we discuss in the course. All right. Okay. So now, do you have any questions regarding this? Do you have any questions?
Cô có thể giảng lại cái chỗ mà cái linear regression model bằng tiếng Việt được không ạ? Cái chỗ đấy em chưa được hiểu lắm ạ.
Okay. Ok. Thì với cái linear regression model, được chưa? Với linear regression model thì các bạn nhớ là các cái có linear regression model là những cái mô hình mà nó có tham số mang vật 1, các cái parameters ấy, đúng không ạ? Nó có cái tham số parameter beta có bậc 1 thì đấy là linear regression model. Đấy chưa? Thì ở đây tất cả các cái mô hình ABC này của chúng ta nó đều có tham số beta mang bậc 1, đúng không ạ? Thì đấy nó là các cái linear regression model, đúng không ạ? Rồi, ở trong mô hình thì như chúng ta nói là nó có 2 thành phần, đó là parameters và cái biến variables, đúng không ạ? Thì một cái mô hình mà nó được gọi là linear, đúng không ạ, thì nó sẽ phải là linear in the parameters, tức là nó có các cái tham số tuyến tính, tham số mang bậc 1. Còn với cái mô hình D này nè, thì các bạn thấy là cái thằng này là nó ở dưới cái dạng đó là loga cơ số tự nhiên, đúng không ạ, logarit cơ số tự nhiên. Thì vì vậy cho nên là thằng này nó không phải, đúng không ạ, nó không phải là một cái thằng mang bậc 1, một cái thằng tuyến tính, đúng không ạ. Vì vậy cho nên là mô hình D này nó không phải là một cái linear regression model. Các bạn có thể dễ dàng biến cái mô hình D này thành một cái linear regression model nếu như mà gì ạ, nếu như chúng ta đặt, đúng không ạ, chúng ta set một cái thằng beta 0 nào đó bằng loganepe của cái thằng beta 1 chẳng hạn, đúng không ạ? Đó, thì mô hình của chúng ta sẽ chuyển thành là gì ạ? Loganepe của y thì bằng beta 0 cộng beta 2 nhân với loganepe của x và cộng với ui, đúng không ạ? Lúc này thì tất cả các cái tham số của mô hình này beta 0 và beta 2 của chúng ta thì đều là các cái tham số tuyến tính, đúng không ạ? Thì lúc đó nó lại là một cái linear regression model, đúng không ạ? Còn với cái dạng này, đúng không ạ? Còn với cái dạng hiện tại này của nó, chúng ta có cái thằng hệ số chặn, đúng không ạ, là loganepe của beta 1, đúng không ạ, thì nó không phải là linear regression model, đúng không ạ. Nhớ là linear regression model là tất cả các tham số của nó phải mang bậc 1, đúng không ạ. Ok, được chưa?
Em ơn cô ạ.
Ok.
Em thưa cô,
Ừ.
cái câu C đấy, khi mà cái hệ số của cái y ở đầu nó có logaritm thì vẫn được tính là linear.
Đúng không ạ, vẫn tính linear. Cái thằng này các bạn coi nó là biến phụ thuộc bình thường thôi, đúng không ạ. Cái mà chúng ta nói là linear ở đây nó phải là cái thằng x này, đó, cái thằng x này nó là linear. Ok, mà với vấn đề là gì ạ? Vấn đề là ở đây chúng ta chỉ quan tâm đến parameters, chúng ta không quan tâm đến các cái biến. Biến nó ở cái dạng nào cũng được ạ, thấy chưa ạ? Biến nó có thể là loganepe, nó có thể là nghịch đảo, nó có thể là bình phương, nó có thể là mũ ba, gì cũng được, miễn là các cái thằng parameter beta của chúng ta nó mang bậc 1 là được ạ.
Dạ vâng cô.
Ok. Ừ. Rồi, what else? Còn gì nữa không ạ? Okay, next. So we have just reviewed some thing from the previous lectures. Now we will continue with our lecture today. Last time we talked about the specifications of a population regression model. We also talked about the specification of the corresponding sample regression model. We say that the sample regression model has the same form, has the same functional form with the population regression model. And if we have sample data, okay, we can easily identify the sample regression model, okay, or we can easily determine the value of the beta 1 hat and beta 0 hat. Okay, so how can we do that? How can we determine, how can we identify the sample regression model, the sample regression line in the coordinate system? All right, so for this we will use the OLS estimation method. The OLS stands for ordinary least square estimation method. And what will we do with this estimation method? How can it help us to estimate the value of the unknown parameters? Okay, let's take a look at how we estimate the regression model. Okay, the problem of estimation. Now, for example, now, okay, so we care about the effect of x on y, okay, or we care about the dependencies of of y on x, okay. So from literature review and from the results of previous researches, we found out that the population regression model, okay, the population regression model has the following form. Okay, from literature review, from the results of previous researches, we find out that the population regression model has the following form. Okay, for example, we have the observed value of y in the population equal beta 0 plus beta 1 times xi and plus ui, for example. This is the population regression model. Okay, so what is the corresponding sample regression model? What is the corresponding sample regression model?
UI equal
What?
beta 0 hat plus beta 1 hat x1 and plus u1 hat.
Okay, xi and plus ui hat. Okay, that is the sample regression model. Okay, so for example, from the population, we take a random sample. Okay, we take a random sample of n observation of x and y. Okay, we have a sample of n observation of x and y. Okay, now we will use this sample to identify the sample regression model, the corresponding sample regression model. All right, so here we have the coordinate system Ox and Oy. For example, this is X and this is Y. Each observation of X and Y will be one point in the coordinate system like this. Okay. For example. Now, can we find a line? Can we find a line that go through all of these observations? Can we find a line that go through all of these points? Can we?
No, it's a line. No.
Yeah, look at this. It is a line, okay? The sample regression function, we can write it as the fitted value of y is equal beta 0 hat plus beta 1 hat multiplied by xi, for example. And this is the function of a line, right? Can we find a line that go through all of these points? The answer is no. No, we cannot do that. We cannot find a line. There's no line that goes through all of these points. Okay, so here, when we identify the sample regression line, we just try our best to find the line that best fit with the sample data we have. Okay, we will try to find out a line that best fit with our sample data. Okay, what does it mean by saying that the line is best fit with the sample data? Okay, so here let's consider this observation, for example. Okay, now look at here we have the observed value of x, and this is the observed value of y. Okay, now this point line on the sample regression line. Okay, this is the sample regression line. Okay, this point line in the sample regression line is the fitted value of y corresponding to this observed value of x. Okay, this one is the difference between the observed value of y and the fitted value of y. We call it the residual ui hat. Okay, all right. When will the sample regression model best estimate or best express the relationship between x and y here? Okay, when will the sample regression line best estimate the value of y, or we can say that it best estimate the relationship between x and y here for this observation only? When will the sample regression line do well in estimating the value of y?
When UI head is mean.
Okay, when UI head is as small as possible, right? When UI head is minimal, and the minimal value is what is it? 0. Okay, there's no difference between the actual value of y and the fitted value of y. Okay, in that case, this sample regression line will best estimate the relationship between x and y, or we can say that it does good in estimating the value of y. Okay, so it means that the residuals is as small as possible. All right, now we have an observation of x and y. We do not care about the difference the UI had in only one observation. We care about the value of UI had for the whole sample of an observation. Okay, there is the difference between the actual value and the estimated value that we obtain from the sample regression model. Okay, so for the whole sample, which um, uh, which um, which variable or which thing can express the difference between the actual value of y and the estimated value of y for the whole sample, of n observations. Okay, uh, this is okay yi minus ui hat. This is the difference, the distance, okay, the difference between the actual value and the fitted value of one observation. Which one will express? How can we express the difference between the actual value and the fitted value for the whole sample? How
We
can
can
we?
average value.
What?
We calculate the average value for each of the observation.
Uh-huh. Okay, so we calculate the residuals for each observation, and then we take the average value of those UI hat, right? Is this your opinion? We calculate the residual UI hat for each observation. All right. Then we take the average of those UI hat. Is that correct?
Yes.
Okay. But remember that UI hat here, some have a positive number and some have a negative number. If you take the average of them, so the positive number will be offset by the negative number, and that will not correctly show the average difference of the whole sample as a whole.
So, so we use the variance and in turn calculate the standard deviation.
The variant, okay, it's good,
Yeah,
but
I think so.
okay, that is the average. Okay, the average distance, but instead of using the average distance between the observed value and the fitted value, we can use the total, okay, the total distance, okay, the total distance between the observed value and the fitted value. Okay, we have yi minus yi hat, and in order to avoid the offset of positive and negative number, okay, we will square it. Okay, so what we care about here is the distance, okay, the distance between the actual value and the fitted value. Okay, so if we have a long distance, this square will have a big value, but if we have a short distance, then this square will have a small value. Okay, so for the whole sample, we can use this one, the sum of all the square difference between the actual value and the fitted value, to show the distance, to express the distance from the observed value to the fitted value. If this distance is long, if this distance is long, then this one will have a big value. Okay, but if the distance between the actual value and the fitted value is small, is short, then these equations, this expression will have a small value. Okay, and when will this sample regression line best express the relationship between x and y? When this one has when will this sample regression line best express the relationship between x and y? Or we can say that when will this line best estimate the value of y? Remember that we use this sample regression model to estimate the value of y. We use yi hat obtained from the sample regression model to estimate the value of y here. Okay, so when will the sample regression line best estimate the relationship between x and y?
I think it's when UI asymptotic equal to 0.
This one, okay, but okay, in one observation, okay, UI hat can be equal to 0, but for the whole sample, UI hat, every UI hat cannot all be equal to 0. Okay, some still will larger than 0, some is smaller than the 0. Okay, we cannot have all the UI hats equal to 0. Okay, but we want to minimize those UI hat. We want to minimize the magnitude, the distance. Okay, khi nào thì cái sample regression model này nó sẽ thể hiện được gần đúng nhất cái mối quan hệ giữa x và y. Thì đây chúng ta có nói là gì ạ? Nhá, cô sẽ nói tiếng Việt để các bạn dễ hiểu hơn.
I think it's when the disturbance. Sorry, the residuals, not disturbance, residuals is. I'm sorry. The residuals doesn't fluctuate much. It doesn't need to be small, but it doesn't fluctuate much.
Okay, it doesn't fluctuate much, but actually, thực ra thì các bạn có thể thấy là ở đây nhá, chúng ta có ở một cái quan sát ấy, đúng không ạ? Chúng ta quan tâm ở đây là gì ạ? Chúng ta quan tâm ở đây là cái khoảng cách từ cái giá trị thực tế đến cái giá trị ước lượng này của chúng ta, đúng không ạ? Chúng ta muốn là cái khoảng cách này nó phải càng nhỏ càng tốt, đúng không ạ? Nó càng ít càng tốt, cái chênh lệch giữa giá trị thực tế và giá trị ước lượng thì nó phải càng ít càng tốt. Tuy nhiên là ở đây, ở một cái quan sát, chúng ta có thể tìm một cái đường nào đó mà nó đi qua điểm này, thì cái chênh lệch ở cái điểm này ấy, nó sẽ là 0, đúng không ạ? Có nghĩa là nó là bé nhất, đúng không ạ? Thế nhưng mà nếu như mà nó đi qua điểm này thì chưa chắc nó đã tốt cho những cái điểm kia, đúng không ạ? Rồi, bây giờ chúng ta cần phải tìm một cái đường nào ấy mà nó phải là tốt nhất cho tất cả các cái điểm, đúng không ạ? Nó tốt nhất cho cái bộ số liệu của chúng ta, chứ không phải là tốt nhất cho một cái điểm nào đó, đúng không ạ? Và điều đấy có nghĩa là gì ạ? Điều đấy có nghĩa là cái khoảng cách, tất cả các cái khoảng cách, đúng không ạ? Từ cái giá trị thực tế đến cái giá trị ước lượng của chúng ta, đúng không ạ? Cái tổng khoảng cách đấy nó phải là nhỏ nhất. Được chưa? Cái tổng khoảng cách của chúng ta ở đây nó phải là nhỏ nhất. Và cái tổng khoảng cách đấy nó nhỏ nhất khi nào? Đúng không ạ? Và nhớ là ở đây chúng ta quan tâm đến khoảng cách, đúng không ạ? Rồi, ở đây là cái chênh lệch ở một quan sát, đúng không ạ? Và để mà thể hiện cái sự chênh lệch ở trong toàn bộ cái mẫu số liệu này thì vừa nãy chúng ta còn nói là chúng ta tránh dùng cái tổng của tất cả các cái thằng y trừ đi y ước lượng. Bởi vì sao ạ? Bởi vì là sẽ có những cái thằng residuals nó là dương, có những cái thằng residuals nó là âm, đúng không ạ? Và nếu như mà chúng ta dùng tổng của các cái thằng y trừ đi y mũ này để mà đo lường, đúng không ạ, cái khoảng cách từ giá trị thực tế đến giá trị ước lượng ở trong toàn bộ cái mẫu số liệu này, thì cái thước đo này nó sẽ bị sai lệch, bởi vì các cái giá trị âm và dương nó sẽ triệt tiêu nhau, đúng không ạ? Rồi, thế còn có một cái cách khác, đúng không ạ? Bởi vì quan tâm đến khoảng cách, đúng không ạ? Chúng ta dùng trị tuyệt đối. Trị tuyệt đối của y mũ, y trừ đi y mũ, đúng không ạ? Chúng ta có thể dùng cái trị tuyệt đối này hoàn toàn được để thể hiện cái khoảng cách, đúng không ạ? Rồi, thế tuy nhiên thì với cái trị tuyệt đối này, cái absolute value này thì nó bị một cái vấn đề, đó là gì ạ? Nó sẽ phải chia ra trường hợp y trừ y mũ nhỏ hơn không thì nó như thế nào, mà y cộng trừ y mũ lớn hơn không thì nó như thế nào. Thì cái việc mà tính toán ở đây thì nó sẽ vô cùng là rắc rối, đúng không ạ? Vì vậy cho nên là chúng ta với cái phương pháp OLS này thì chúng ta sử dụng, đúng không ạ? Sử dụng một cái thước đo để đo lường tổng khoảng cách từ cái giá trị thực tế đến cái giá trị ước lượng của chúng ta, giống như ở trong cái khi mà chúng ta tính phương sai, đúng không ạ? Đó là gì ạ? Hoặc là giống như khi mà chúng ta đúng rồi, chúng ta tính phương sai, đó là gì? Chúng ta lấy y, đúng không ạ, trừ đi y mũ, đúng không ạ, và tất cả bình phương lên, đúng không ạ, để mà thể hiện cái tổng, đúng không ạ, cái tổng chênh lệch giữa cái giá trị thực tế với cái giá trị ước lượng của chúng ta, đúng không ạ? Nó là một cái thước đo để nó tương ứng với cái tổng đó thôi, đúng không ạ? Nó không phải là cái tổng chênh lệch đó, nhưng nó là một cái thước đo, đúng không ạ, tương ứng với cái khoảng cách từ giá trị thực tế đến giá trị ước lượng ở trong toàn bộ cái mẫu số liệu này, đúng không ạ? Rồi, thế thì ở đây khi mà các cái khoảng cách này nó càng ngắn, đúng không ạ, cái khoảng cách đối với cả cái bộ số liệu này nó càng ngắn thì cái đường hồi quy mẫu này nó lại càng thể hiện tốt cái mối quan hệ giữa x và y của chúng ta, đúng không ạ? Và nó thể hiện tốt nhất khi nào? Khi mà cái thằng này của chúng ta đạt giá trị nhỏ nhất, đúng không ạ? Khi mà cái thằng này nó đạt giá trị nhỏ nhất thì cái đường hồi quy mẫu đó nó sẽ thể hiện được gần đúng nhất cái mối quan hệ giữa x và y của chúng ta, hay nói cách khác là nó ước lượng tốt nhất cái mẫu cái mẫu y này của chúng ta, đúng không ạ? Đó, thì ở đây vừa nãy thì các bạn có nói là chúng ta dùng variance hoặc là chia ra, đúng không ạ? Thì đấy nó là cái biến động trung bình thôi, đúng không ạ? Thì biến động trung bình cũng được, nhưng mà đối với cái phương pháp OLS thì chúng ta xem xét cái tổng biến động ở trong cái mẫu số liệu của chúng ta, đúng không ạ? Và cái tổng biến động này ấy, nó càng nhỏ, đúng không ạ? Cái tổng chênh lệch này nó càng nhỏ thì cái đường hồi quy mẫu lại càng thể hiện được tốt cái mối quan hệ giữa x và y ở trong cái mẫu số liệu này, đúng không ạ? Và khi mà nó đạt giá trị nhỏ nhất ý, thì đấy nó chính là cái đường hồi quy mẫu mà chúng ta cần tìm đối với cái phương pháp OLS này của chúng ta. Được chưa ạ? Chỗ này các bạn có hiểu không ạ?
Có.
Ok, good. Ok, vậy thì now how can we find the sample regression model, okay, that results in the minimum value, okay, the minimum value of this one. This one we call the sum of square residuals. Okay, ui minus ui hat is equal to residuals ui hat. So this one is equivalent to the sum of r square ui hat. Okay, so which sample regression line will result in the minimum value of the sum of square residuals? Okay, we will try to find that out. Okay, now we have the sum of all square residuals equal, okay, so the observed value of y minus the fitted value of y squared, okay, and this is equal to the sum of all yi hat, yi minus beta 0 hat minus beta 1 hat multiplied by xi and square. All right. Now, our duty here, okay, our job here is to find the value of beta 1 hat and beta 0 hat so that this expression will have the minimum value, okay, so that this one will have the minimum value. Okay, so when will a mathematical expression have the minimum value a maximum value, or we say that it has the extreme value. When you have studied it in high school, okay, when a mathematical expression obtain or get the minimum value,
We derive.
okay, we take the first derivative, okay, when the first derivative of this one is equal to 0, okay, and the second derivative of this one is larger than 0, okay, and but we will not use the second derivative. We will just use the first derivative to calculate the value of beta 0 hat and beta 1 hat. Okay, so in this expression, okay, in this expression, given that, okay, remember that we already have a sample of an observation of x and y. So we have to find the value of beta 0 hat and beta 1 hat so that this expression receive, okay, or get the minimum value. All right. So we have two roots here, that is beta 0 hat and beta 1 hat. And we have to find the value of those roots so that this one will get the minimum value. Okay, this one will get the minimum value. Now we will take the first derivative of this expression with regard to beta 0 hat and with regard to beta 1 hat. And that first derivative must be equal to 0. All right. So do you remember the way that we take the derivative in high school? For example, if we have u is a function of x, okay, u is a function of x, and what is the derivative? U square, u with the power of alpha. Okay, what is the derivative? The first derivative of u with the power of alpha?
Alpha times u will hit alpha minus 1.
Okay, u
With the
alpha,
power.
yeah, multiply by u with the power of alpha minus 1 and multiply by the derivative of u.
Of u.
Yeah, okay. So here, let's take the derivative of this one with regard to beta 0 hat. Okay, what is the derivative of this one? We take the derivative of the sum of square residuals, okay, with regard to beta 0 hat. What is it? Equal to times the sums of yi minus beta 0 hat, yeah, minus beta 1 hat multiplied by xi and multiplied by, what is the first derivative of this one in the parentheses with regard to beta 0 hat?
Minus 1.
Yeah, minus 1, that's right. And this one must be equal to 0, okay? And also we must have the derivative, okay, the first derivative of the sum of square residual with regard to beta 1 hat. Okay, what is it? 2 times yi minus beta 0 hat minus beta 1 hat multiplied by xi and multiplied by, what is it?
Minus xi.
Minus xy.
Yeah, minus xi. And this one is also equal to 0. All right, so we will cross out some constant here. Okay, cross out. Then we will have an equivalent set of equations. Okay, so we have here the sum of yi minus, what is it? Let's break down this one. Break down this one. We have the sum of yi minus, okay, with I equal 1 to n. Okay, what do we have here? The sum of all yi minus, remember that beta 0 and beta hat, beta 0 hat and beta 1 hat are constant.
N times beta 0.
Yeah, 10 times beta 0 hat, okay, and minus beta 1 hat multiplied by the sum of xi. Okay, this one must be equal to 0. And the lower equations, we have the sum of yi multiplied by xi, okay, minus beta 0 hat multiplied by the sum of xi and minus beta 1 hat multiplied by the sum of xi squared, okay? And this one, it must also be equal to 0. All right, so remember that we have a sample of n observations in hand, okay? Can we calculate the sum of all yi? Can we calculate the sum of all yi? Hmm? We already have a sample of n observations. All right. Can we calculate the sum of all y in the sample?
Yes.
Yes. All right. Do we know the value of n?
Yes.
Yes. And the same happen, we can also calculate the sum of all xi. We can calculate the sum of the products between yi and xi, okay? And we can also calculate the sum of all square xi, okay? So this one become a set of equations with two roots, that is beta 0 hat and beta 1 hat. Can we solve for this set of equations? Can we solve for the value of beta 0 hat and beta 1 hat?
Yes.
Yes, of course. We have two equations and we have two roots. It is possible, okay? It is possible to solve for the value of beta 0 hat and beta 1 hat, okay? And solve this set of equations, we get the following, we get the following root here, okay? The following roots here with beta 0 hat is equal to the, what is it? The sample mean of y minus beta 1 hat multiplied by the sample mean of x, okay? And where beta 1 hat is equal to this one, the sum of all yi multiplied by xi minus n multiplied by the sample mean of x and multiplied by the sample mean of y, okay? This, in the denominator, we have the sum of all square x minus n multiplied by the square of the sample mean of x, okay? So this is the formula to calculate the value of beta 0 hat and beta 1 hat, okay? If we have a sample of n observations in hand, we can easily plug in the number, okay? Plug in the number to calculate the value of beta 0 hat and beta 1 hat, okay? Now, for example here, we have xi, small xi, okay? If we set small xi equal the observed value of x minus the sample mean of x and small yi equal the observed value of y minus the sample mean of y, then beta 1 hat can also be calculated by using this formula, okay? It is also equal to the sum of small x multiplied by the small y divided by the sum of all square small x, okay? And these are the formula that we can use to calculate the value of beta 0 hat and beta 1 hat by the method of ordinary least square. Okay, so with the method of ordinary least square, we will try to identify the sample regression model. Okay, we will identify the sample regression model that minimize the sum of square residuals. Okay, and this is the criterion. Okay, the criterion to identify the sample regression model. Okay, so that the sum of square residuals has the minimum value. All right, remember that. Now, there's some probability, properties of beta 0 hat and beta 1 hat that you have to remember. So because we derive beta 0 hat and beta 1 hat by the OLS estimation method, so that we can call beta 0 hat and beta 1 hat the OLS estimators, okay, because they are derived by the OLS estimation method. Okay, so next time when we talk about OLS estimator, we are talking about the beta hat. Okay, now beta 0 hat and beta 1 hat, okay, are point estimator, which means for a given sample we only get we only get a certain value of beta 0 hat and a certain value of beta 1 hat. Okay, for a given sample, we only have a certain value of beta 0 hat and a certain value of beta 1 hat. Okay, which means that each estimator will provide a single value of the relevant population parameters. Okay, but for different sample, okay, because then for different sample, we will have different sample value, a sample mean of y. We will have different sample value, a sample mean of x. Okay, we will also have different summations. Okay, we will have different value. That's why for different sample, we will have different value of beta 0 hat and beta 1 hat. Okay, which means that beta 0 hat and beta 1 hat are random samples. Okay, for one certain sample, they only have a certain value, but for different sample, they will have different value. Okay, so because they are random sample, then later we will talk about the expected value of beta 1 hat and beta 0 hat. And we will also talk about the variance of beta 1 hat and beta 0 hat. Okay, remember those, these are the, statistical properties of beta 0 hat and beta 1 hat of the OLS estimators. All right. Now, we have an example here so that you can practice with the formula, okay, with the formula we have just derived with the OLS estimation method. Okay, we have an example here. We want to estimate the dependencies of wage on the years of education. Okay, so we have the following data for wage denoted as Y and the years of education denoted as X in the model. So for question A, based on relevant theories, based on the result of previous researches, identify which variable is the dependent variable and which one is the independent variables, and specify the population regression function. Okay, and for the second questions, estimate the model using the provided data. All right, now let's do this. Use the that we have just developed. Now, anyone? Any volunteer who can help me with this example? We already have the formula, okay? The first one, for the first questions, you have to develop the population regression model first, and then we use the data collected here to estimate the model, which means that we determine, we specify, okay, we identify the sample regression model by this data. Any volunteer? Is it hard?
Can I volunteer for it?
Yeah. Who you are? Who are you?
I'm Nguyễn Ngọc Hà. I'm raising my hand right now.
Okay, Nguyễn Ngọc Hà. Oh my goodness. I thought you was a girl. Sorry.
That's all right. I get that a lot.
Okay. All right. Okay. Yeah.
Can you show me the slides so that? Yeah, thank you.
Okay. Now,
So
first question A. Please identify. Please follow the methodology of econometrics to do these problems. Okay. So firstly, we have to specify the population regression model first. Okay.
Okay, so I assume that the observed value yi
Mm-hmm.
is corresponding to the wage,
Mm-hmm.
and xy corresponds to education.
Okay, so we have yi is the wage of worker. Okay, and x value is the years of education. Okay. Okay. Next, which one is the dependent variables?
I think that wage is the dependent variable.
Mm-hmm. Don't say that I think. Okay, you say that. Okay, based on some previous researches, for example. Okay, we can see that wage depends on the years of education. So here, the dependent variables is wage. All right.
Yes.
Okay. Now wage is the independent variable. Sorry, dependent variables. Okay. And what is the population regression model?
The population regression model.
Mm-hmm. Mm-hmm. Okay. We have yi.
Yi equals to
Mm-hmm.
I'm on the way of calculating the parameters.
Wait. We do not calculating the parameter. We just estimate the parameters. Remember that. We do not have the population data. We do not have the data of the whole population, so that we cannot calculate the parameters. We just remember that here for the population regression model, you just specify the form of the population regression model. We cannot calculate beta 0 and beta 1. Okay? So here, just write the form of the population regression model. Okay, that is
yi equals to beta 0 hat plus beta 1 hat times
no, no,
xi.
sorry. In the population regression model, remember that in the population regression model, do we have the sample estimators?
No, but I
No.
thought the observations here are just a sample. So
Yeah, because the observation here is just the sample, then, but we still have the populations model. Nhá, các bạn nhớ này. Ok, các bạn nhớ là ở đây nhá, theo như cái quy trình ở trong cái methodology of econometrics thì các bạn nhớ là chúng ta phải specify cái mối quan hệ giữa các cái biến trước. Đúng không ạ? Chúng ta phải xây dựng cái mô hình, cái population regression model first. Đấy chưa? Đó, thì từ cái population regression model đó thì các bạn mới có được cái corresponding sample regression model, đúng không ạ? Và dùng cái số liệu để mà chúng ta identify cái sample regression model đó. Và cái bước đầu tiên vẫn là phải đưa ra cái specification của cái regression, của cái population regression model đó đã, đúng không ạ? Còn nhớ là gì ạ? Cái population regression model đó thì không phải là chúng ta rút ra từ số liệu đâu, mà chúng ta rút ra từ lý thuyết, từ các cái nghiên cứu đi trước, được chưa ạ? Và vì vậy cho nên là gì ạ? Ở đây cái bước đầu tiên là phải xác định được là cái dạng quan hệ giữa x và y ở đây của chúng ta nó có dạng như thế nào, đúng không ạ? Chính là cái việc mà chúng ta xác định cái population regression model của chúng ta đấy ạ, đúng không ạ? Và nhớ là đối với population regression model nhé, bởi vì chúng ta không có population data, cho nên là các bạn sẽ không bao giờ tính được chính xác giá trị của beta 0 và beta 1. Vì vậy cho nên là chúng ta cũng không bao giờ chúng ta thay bất kỳ cái số gì vào cái population regression model này cả, và chúng ta chỉ để nó dưới cái dạng tham số beta 0, beta 1 như thế này mà thôi, được chưa ạ? Ok. Rồi, và nhớ là population regression model thì cũng không bao giờ có cái thằng beta 0 và beta 1 cả. Đúng không ạ? Bây giờ thì chúng ta chưa làm gì với cái sample regression model đâu. Hiện tại bây giờ chúng ta mới chỉ ở cái bước, đúng không ạ? Hiện tại đây, cái bước mà chúng ta đang làm ở đây, chúng ta chỉ mới ở một cái bước, đó là cái bước specify cái population regression model đã. Đúng không ạ? Thì sau khi có cái population regression model rồi thì chúng ta mới có được cái corresponding sample regression model. Được chưa? Okay. So next, now continue to specify the form of the population regression model.
Yes, b1 times xi ui
and plus ui. Okay. So this is the population regression model that show the dependencies of which y on the years of education x. Okay. Okay, that is the questions A. The answer for questions A. But remember, when you do the project, you have to explain this more carefully. Okay, we have to explain which one is the dependent variables and which one is the independent variables more carefully, more detailed. Okay.
Yes.
Okay, for questions B, we have to estimate the model. Okay, so this one means that, okay, specify the sample regression model. Okay, sample regression model corresponding to this sample size with to this collected data regression model.
Oh, I see.
Yeah. We estimate the population regression model. We cannot identify, we cannot determine the population regression model. We can just estimate it because we do not have enough data to calculate it. We can just estimate it, and we estimate the population regression model by the sample regression model. Okay? All right. Wait a minute. I have to relocate. Okay, just wait a minute. My little girl will take her online course now, so I have to relocate so that her can start it. Just wait for 2 minutes. I have to set up for her. Sorry, let's continue. Now we will estimate the model by the sample that we have here. We have 6 observations. So, okay, how can we identify the sample regression model here? Use the formula that we have just derived from the OLS estimation method. Okay, are you there?
Yes. I've been listening. Yes.
Okay, so what is the value of beta 1 hat? How can you calculate the value of beta 1 hat? We have the formula already. Okay, now you just have to plug in the number into the formula.
We calculate the mean of x and y.
We calculate the sample mean of x and y. What is the sample mean of x?
7.5.
What is it?
7.5.
Okay, 7.5. And what is the sample mean of y?
10.5.
10.5.
I think he has some mistakes. I mean, the weight is the variable y, so
Yeah, I think so. So we have x is the year of educations, and y is the wage received by the workers. Then the sample mean of x must be this one must be what is it? 10.5. And the sample mean of y is 7.5. Yeah. Now, what is the sum of the products between yi and xi?
501.
Okay, 500. See, 501.
Yes.
And what is the sum of square x?
Is equal 679.
679. Okay, and what is n?
And is equal to 6.
6. Okay, now just plug in the number into the formula. We can have beta 0 equals 501 minus n, which is 6,
6
multiplied by 10
10.5
and multiplied by 7.5. Okay, divided by
679
minus
minus
6
6 times 10.5 square.
squared. Yeah, and what is the value of beta 0, beta 1 hat?
Equal 1.6.
1.6. All right. And beta 0 hat, what is it? We have beta 0 hat equal
Minus 9.5.
which is 7.5 minus 1.6 multiplied by 10.5, and what do we get?
Minus 9.3.
9.3. So our sample regression model here, what will be the sample regression model?
Is a yi has equal minus 9.3 plus 1.6 xy.
Yeah, multiply 1.6 times xi. That is the sample regression model. Or we can express it in the stochastic form, which is minus 9.3 plus 1.6 times xi and plus ui hat. Okay, so this is called the sample regression model or the estimated model. Okay, the estimated model. All right. Remember, do not replace beta 0 hat and beta 1 hat into the population regression model. Do not do that, all right? Because beta 1 hat and beta 0 hat are totally different from beta 0 and beta 1. They are two different things, all right? Okay, so that
Cô
is
ơi,
how...
cho em hỏi em.
hỏi đi.
Tại vì em thấy là nếu mà này là sample thì mình phải tính theo sample mean, thì tức là phải là chia cho n là bằng nhầm, phải chia 6 trừ 1 là chia 5 thì sẽ ra cái mean khác ạ, chứ không phải là mean này là tính theo population mean ạ.
Sample mean thì không cần phải là trừ 1 đâu. Chỉ có cái variance với cả cái covariance mới là n minus 1 thôi. Còn với cái sample mean ấy thì các bạn sẽ chia cho n chứ không phải là chia cho n trừ 1.
Dạ vâng, em cảm ơn ạ.
Okay.
So we assume that the sum of ui hat is always minimum in these cases.
The way we derive the formula, các bạn nhé, cái cách mà chúng ta lấy được cái công thức của beta 0 mũ và beta 1 mũ ấy, the way we derive the formula, we already assume, okay, we already assume that the sum of ui hat is equal to 0. It has the minimum value. Okay, tức là chúng ta đã phải lấy cái điều kiện, đúng không ạ? Chúng ta đã phải bây giờ trong cái trường hợp mà ui hat equal square, đúng không ạ? Tổng của các cái thằng ui mũ bình phương đó nhỏ nhất, đúng không ạ? Thì chúng ta phải có điều gì, đúng không ạ? Thì Tức là chúng ta có hai cái phương trình mà chúng ta sử dụng để chúng ta giải ra beta 0 mũ và beta 1 mũ đấy ạ. Có đúng không ạ? Tức là trong cái trường hợp mà nó nhận giá trị nhỏ nhất nhé, thì chúng ta phải có cái điều đó. Đúng không ạ? Và chúng ta sử dụng chính hai cái điều đó để chúng ta giải ra beta 0 mũ và beta 1 mũ. Vậy thì cái beta 0 mũ và beta 1 mũ đấy chính là cái giá trị mà làm cho cái tổng của các cái thằng UI mũ của chúng ta nó nhỏ nhất. Có đúng không ạ?
Vâng. Nhưng mà em tưởng là cái gốc rễ để làm cái UI đấy nhỏ nhất thì là cái model mình chọn, mà cái đấy thì lại bắt nguồn từ cái theory mà mình sử dụng để nghiên cứu đấy.
Rồi nhá, cái theory mình sử dụng để nghiên cứu tức là như thế này. Ở đây nhá, thì cái theory mình sử dụng để nghiên cứu sẽ giúp cho chúng ta xác định được cái population regression model, đúng không ạ? Rồi, bây giờ ví dụ như là tôi xác định được cái population regression model của tôi nó là một cái đường thẳng đi chẳng hạn, đúng không ạ? Thì vậy thì đương nhiên là cái sample regression model của tôi nó cũng là một cái đường thẳng, đúng không ạ? Và cái việc mình xác định nó là cái sample regression model nào ở đây thì nó không phải là xác định sample đấy nó là đường thẳng hay đường cong, bởi vì là population nó đã là đường thẳng rồi thì chắc chắn sample nó sẽ là đường thẳng. Cái việc mình xác định cái sample regression model ở đây chỉ là nó là đường thẳng nào trong số những cái đường thẳng ở trên hệ trục tọa độ của chúng ta mà thôi. Hiểu không ạ?
Sorry, can you repeat that in English again, the last points?
The last point. So I get it. I have a questions that can you ask that questions again?
Yes. So I asked the question that do we always assume that the sum of UI with a hat are minimum, because the very reason why we minimize it is due to the theory that we use to conduct the experiment?
Okay, so as I have said, we develop this population regression model based on literature review and the results of previous researches. Okay, so based on previous researches and literature review, you can identify whether the population regression model has a linear function or a non-linear function, for example. Okay, and the corresponding sample regression model will have the same functional form, okay, as the population regression model. And the thing that we do here, we use the data, the sample data, to identify the sample regression model. It just find the line. Okay, for example, if the population regression model is a line, then the sample regression model is also a line. Okay, and the way that we use the data here to identify the sample regression model is just to find the line which lie in the coordinate system result in the minimum value of the sum square residue, sum of square residuals. Okay, so here when we find that sample regression model, we already assume, okay, that line will result in the minimum value of the sum of square residuals. Okay, and we use the condition when will the sum of square residue receive or get the minimum value. We use the condition that is the first derivative of the sum square residue with regard to beta 0 hat and beta 1 hat. Okay, the first derivative must be equal to 0. We use that condition to solve for the value of beta 1 hat and beta 0 hat. So the beta 0 hat and beta 1 hat that we get, okay, will obviously result in the minimum value of the sum of square residuals. Is that okay?
Yes, thank you.
Ha, do you get that?
Yes, I do. Thank you.
Yeah. Okay. So any questions here? All right. So based on the sample regression model here, we can understand more about the relationship between the dependent variable and the independent variables. And here is the relationship between the wage and years of education. For example, here we have, all right. So this is the sample regression model. All right. We have two ways to express the sample regression model. And with beta 1 hat, it is the positive number, then the relationship between wage and education are positive relationship. Okay, which means that when education increase, wage is also wage tends to increase as well. And because this is the regression model, then we can say that education affect the value of wage. Okay, and when beta 0 hat, because beta 0 hat is equal to 1.6 to 9, all right, then it means that when the years of education increase by 1 year, the wage of worker is expected to increase by 1.6 to 9 million dollars per month. Okay, that is the meaning of beta 1 hat. We have just quantified the relationship between education and wage, how the education affect the wage received by workers. Okay, and remember that this level of increase, this increase is the average increase in all cases. For example, for this worker, when his year of education increased by 1 year, the wage received by him, okay, increased by 1.7 million dollars per month. But for that worker, when the years of education increased by 1 year, the wage he received just increased by 1.6 million dollars per month. Okay, but on average of every cases, on average of all cases, the wage of worker is expected to increase by 1.6 to 9 million dollars per month. Okay, usually when we explain the sample regression model, we usually explain the meaning of the slope. Okay, this is the slope, the estimated slope. It shows the effect, it shows the direct effect of the independent variables on the dependent variables. Okay, but for the intercept, it just helps us to more correctly estimate the value of wage. Okay, all right, that is the sample regression model. Do you have any questions here? No? Okay, so let's what will we do now? Let's take 10 minutes break. Okay, let's take a 10 minutes break. Then we will come back and we will talk about what you have done with the group work. Okay, I will ask you some questions about that. All right, let's take a 10-minute break. Okay, class, are you back yet?
Yes.
Okay, good. So we have just talked about the estimate, the OLS estimation method. Okay, we use the OLS estimation method to estimate the population regression model by a collected data. Okay, now, okay. We still have some properties of the sample regression model derived by the OLS estimation method. Let's talk about that. Okay, we still have one more example. Okay, we want to know the dependencies of the excess return on a portfolio. Okay, how it depends on the excess return of the market index. Okay, so you can do this at home. Okay, if you have any questions, you can ask me. We have 5 observations on the excess return of a portfolio and the excess return on market index. Okay, in finance, we say that the excess return of a portfolio depends on the excess return of the market index. Okay, so you can you can construct a population regression model to show the relationship between these two variables and use the provided data here to estimate that model. Okay, and the slope of that model will be the beta of a portfolio. Okay, beta of the portfolio. So the what volatility of the return on an asset with regard to the return of the market index of the market of the overall market. Okay, all right. Now we have some properties of the sample regression model derived by the OLS estimation method. Usually those property we will not use it. We will not talk about those properties in our work later, but you just have to know that the sample regression model, the sample regression line has some properties like this. The first one, the first properties of the sample regression model of the sample regression line is that it's passed through the sample mean of x and y, which means that we always have the mean value of y is equal to beta 0 hat plus beta 1 hat times the sample mean of x. Okay, that is because you can look at the way we calculate the value of beta 0 hat. We calculate beta 0 hat by by subtract beta 1 hat times the average mean of x from the average mean of y. Okay, the sample mean of y, sorry, and that's why the sample regression line will always passes through the sample mean of x and y. Okay, another point is that the average of all the fitted value of y, okay, for each value of x, you can have a corresponding fitted value of y, and the average and the mean of those fitted value of y is equal to the sample mean of y. And this also means that, okay, the average value of the residuals is equal to 0. Okay, because because we have the observed value of y equals the sum of the fitted value and the residuals. So when we take the average of the left side, okay, in the right side we also have the average of the fitted value of y plus the residual ui hat, okay, and the okay, I will have to use my pen. It's very hard to explain in words. Okay, so we have the observed value of y equal the fitted value of y plus ui hat. Now take the average of the left side. We have the expected value of y equal the expected value of yi hat and plus ui hat, and this is equal to the expected value of yi hat plus the expected value of ui hat. Okay, and because the expected value of y equal the expected value of yi hat, yeah, we have it here. So of course the expected value of ui hat will be equal to 0. You can check this, okay, you can check this by replace using, you can check this by using this example. We have the sample regression model already, okay, the sample regression model like this, okay. You just replace the year of education here and get the estimated wage, all right, and you take the observed value of wage minus the estimated value of wage, then you will get the residual ui hat, okay. And if you if you take the sum of all the ui hat that you get, okay, that sum will be equal to 0 or will be approximately equal to 0, because we have some calculation calculation route somewhat some calculation approximation here, okay. All right, so you can check that. Okay, what else do we have? That is the third properties of the sample regression model. And also if we have the sample regression model derived by the OLS estimation method, we also have this residuals are uncorrelated with the fitted value of y, and the residuals are uncorrelated with the independent variable x. Okay, so that we have the correlation coefficient between ui hat and yi hat, and the correlation coefficient between ui hat and x, they are all equal to 0. Okay, that is some properties of the sample regression model. Okay, you just have to know that. Maybe we will not use them later. It's not very useful for our analysis. Okay, the basic assumption of the OLS estimation method. We will talk about this later. We will talk about this in the next lecture. Now just spend more time on the group work. Okay, spend more time on the group work. Let's see. We have our group here. And we have 22. Okay, we have 22 groups. You all have your you all have your interested topic. Okay, so let me ask you some questions. For group one, we have, how many members do you have? You have 5 members. Okay, now remember to fill in the student ID here of those members. You care about the effect of the relationship between Federal Reserve fund rate and economic growth. Okay, so where's group one? Group one, where's group one? Where are you?
Dạ em đây ạ.
Why do you want to find Federal Fed fund rate and economic growth? Economic growth of what? Of a country or of the United States or of a region?
Em có cái này là của nước Mỹ ạ.
Of the US, okay. What else? Which one is the dependent variables and which one is the independent variables?
Em có cái giờ cái independent là cái Fed fund rate, còn cái dependent là economic growth.
Giữa hai thằng này có mối quan hệ như thế nào?
Em cô cái giữa hai thằng này nó có mối quan hệ đó là khi hai thằng này có mối quan hệ là khi cái Fed fund rate nó giảm thì cái economic growth nó tăng ạ.
Which economic theory state that which researchers show the relationship? Các bạn lấy cái cơ sở nào để các bạn nói như vậy ạ? Tại sao cái Fed fund rate nó tăng thì cái economic growth nó lại giảm đi ạ?
Tại vì cái lý thuyết này em lấy ở trong kinh tế vĩ mô và
đó là thuyết nào?
Nếu em nhớ không nhầm thì đây là thuyết ở trong chính sách ở chính sách tiền tệ ạ.
Chính sách tiền tệ, ok. Cái đấy là tức là mình phải có cái trích dẫn đầy đủ nhá, chứ không phải là em nghĩ như vậy hay là nếu em nhớ không nhầm thì là như vậy, mà mình phải có cái literature review và mình phải có cái trích dẫn đầy đủ. Chẳng hạn như là theo như lý thuyết chính sách lý thuyết tiền tệ, tác giả của nó là ai chẳng hạn, ví dụ như là cái ông A này chẳng hạn, theo ông A năm bao nhiêu đấy trong cái quyển chính sách tiền tệ cái gì đấy thì đã cho rằng là cái mối quan hệ giữa các cái biến nó như thế này chẳng hạn, ví dụ là như vậy.
Alo, em thưa cô, em là thành viên của nhóm 1 đấy ạ. Thì em cũng có muốn góp ý một phần cho ý của bạn Huy. Đấy là chúng em lấy cái relation này từ thebalance.com, một bài viết được đăng trên The Balance bởi ở chuyên mục US Economy, có bài có tên là US Inflation Rate by Year from 1929 to 2023 by Kimberly Emmetted. Và cái bài viết này nó có nói rằng là trong cái business cycle có cái expansion, có peak, contraction and truth, thì cái thời điểm mà khi mà nó có cái nó tạo ra cái inflation rate đấy ạ, thì the Fed sets a target inflation rate of 2%, and if the core rate rises much above that thì the Fed will execute a contractionary monetary policy. Cái này là cái bạn Huy vừa nói lúc nãy. Và this contractionary monetary policy sẽ increase cái federal fund rate, chính là cái biến của chúng em ấy ạ. Và và cái biến này thì nó sẽ thì khi mà cái federal fund rate này nó sẽ tạo ra cái effect lên cái GDP growth rate, nhưng mà cái độ trễ nó khoảng 4 năm cô ạ.
Okay.
Cái bài này với cả một cái bài nữa là bài US real GDP growth rate by year compared to inflation and employment cũng bởi Kimberly Amaded. Thì Amadel thì bọn em có combine hai cái bài viết này lại và lấy cái data từ hai cái bài research này ạ để kết luận ạ. Vâng.
Ok, như vậy ở đây các bạn muốn dùng cái federal fund rate để các bạn explain cái economic growth of the US đúng không ạ?
Vâng.
Ok. Alright. Và cũng có cái cơ sở, đó là các cái bài viết mà nó đã nghiên cứu về vấn đề này trước đây rồi, đúng không ạ? Ok, các bạn đã có được data chưa ạ?
Dạ bọn em có data rồi ạ, và bọn em có cho chạy trên Stata rồi ạ.
Okay, good. Alright. Giờ thì bây giờ các bạn chỉ việc đã quên mất. I forgot. I have to tell you how to use data to estimate the model. Alright. So okay, later I will tell you about that. In the beginning of the next lecture, we do not have much time for that. Okay, rồi cảm ơn nhóm 1 ạ. Okay, and group 2, CO2 emissions and the world forest area. Okay. Okay, Wes, group 2. Where are you?
I'm here.
So which one is the dependent variable and which one is the independent variable? And what is your the reason why you choose the two variables?
I think the carbon dioxide emission is the dependent variables, and the forest area is the independent variables.
Okay. And the reason for that?
The reason why we chose this topic
why you use the world forest area to explain the value of the carbon dioxide emission?
We think because the reducing forest area is one of the main reasons for excessive carbon dioxide emission, and we have abundant information about the forest area, so we just pick that topic.
No, don't say that. I think, okay, you have to base on scientific reasons. Okay, you have to have scientific reasons to choose the variables in the model. Được chưa? Nào các bạn đừng nói là tại vì em nghĩ như vậy nhé, đừng nói như vậy, mà các bạn cần có cái cơ sở. Được chưa? Cái cơ sở là tại sao mà các bạn lại sử dụng cái World Forest Area để explain cái CO, cái thằng CO2 emissions của mình. Được chưa? Đó. Cái cơ sở đó là gì? Đó là em phải đọc các cái nghiên cứu đi trước mà nó đã nghiên cứu về những vấn đề này rồi, đúng không ạ? Rồi chẳng hạn như là những cái nghiên cứu đi trước mà những cái nghiên cứu mà nó giải thích về cái carbon dioxide emission này, đúng không ạ? Nó sử dụng những cái yếu tố nào để nó giải thích những cái điều đấy, và có những cái yếu tố nào có ảnh hưởng đến cái carbon dioxide emission mà các cái nghiên cứu đi trước nó đã chỉ ra. Được chưa? Và em lựa chọn cái biến như thế này, một trong số các cái biến đó để em explain cái carbon dioxide emission này nhá. Phải chỉ ra cái điều đó, được chưa? Chứ không phải là nói là em nghĩ cái điều đó đâu ạ. Được chưa? Rồi. về ghi rõ cái phần này ra nha, được chưa?
Vâng, vâng.
Have you collect the data for this?
Yeah, we
How
have
many? Yeah, how many observations do you have? How many observations do you have?
About 6.
6 observation. Hơi ít, hơi khiêm tốn nha. Yeah. Okay, so when you have the observations, you can use the observation and use the method, the OLS estimation method, to estimate the relationship between them. Try to find as many observations as possible. Okay? Later, when we study the chapter of multiple regression model, I will ask you to find more independent variables to explain your dependent variable here. So remember to find some some sample, to find a sample that you can also collect the data of other variable as well. Okay. And possibly you will use this topic. You will use this topic for your group work submission. Okay. Now you first develop the topic by find the dependent variable and one independent variable. Later, you will have to find more independent variable to explain your dependent variables, and you will use that topic for your group work submission at the end of the course. So remember to think carefully about your topic, to think carefully about something that you can collect the data of them, and my requirement. Okay, my requirement for the number of observations in the sample must be at least 40 observations. Okay, 40 observation at least. Okay, but if you can find more observations for your sample, it will be better. Okay, all right.
Okay, thank you for the feedbacks.
Okay, we still have some more group here. So all right, so as I have said, later when we study the multiple regression model, I will ask you to find more independent variable to explain the dependent variables. So remember to think of a topic that you can find the data for many variables that we care about. All right, so please think of your topic again. All right, and remember that you will have to have at least 40 observations. Okay, all right, do all got it?
Yes.
Okay, good. If you have any other questions, you can email me or send me a message. All right. Okay. So today our lecture ends here. Okay. Do you have any questions regarding the thing we discussed today, or the group work or something like that?
About our group work, so we this we researched about the income and consumption of the German of Germany. Sorry, but then it doesn't show the sample size. It just show the uh, the spending, the average the average income and how they spend that amount of money. They just don't show the sample size. So is that okay, or do we need to find other sources?
Excuse me, I don't understand your questions. They don't show the sample size. What is it? How many observations do you have?
Like that's the problem because they don't show the sample size, so we don't know how many observations that they had. So I kind of assume that
Ah,
they've done the research on the whole population.
oh, okay. So you misunderstanding the concept of observation here. Okay. Now, because you care about the relationship between income and consumption of the Germany, so each year, okay, each year or each month or each quarter, it is an observation. All right.
Ah, okay.
Yeah, we don't care about how many people does the data collector use in for collect the data on the whole Germany. Okay, we just care about the number for the whole country. Okay, we care about the number for the whole country, and each time, each point in time, for example, each year or each quarter or each month, it is an observation. Do you got it?
Yes. So here's the problem. I
Mm.
mean, there are different categories for the income of the
Oh,
population. So
yeah.
I I consider that the amount of the number of observation to calculate to estimate the function for 1 year. So we have to repeat that for all for every other years in order to get the desired outcome.
Mm. Mm. What data do you have?
We had the GDP. Sorry, we had the income. We had the income table of Germany in 2002, and also it shows how people spend that money, spend their income.
Oh, so you have the data for only 2020, right?
Yes, yes,
And in that set of data, you have the income of Germany as a whole, and you
yes.
also have the spending, the consumption of Germany in different area.
Like they do
So
not.
Okay, you can send me your data. Okay, you can send me your data, and I will have a better understanding of your data and better understanding of your questions. Okay, then I will give you the answer later. All right.
Okay,
Okay, thank you.
thank you.
Okay. Any other questions? All right. So we will stop here. See you on Friday. Bye bye.
Goodbye.
Bye.
bye.
Bye, teacher.
Goodbye,
Goodbye,
teacher.
teacher.
Goodbye.
Bye.
Goodbye, teacher.